Example 4, find all complex number solutions of x to the 5th minus I equals 0. I actually want to change this to a 1. So let's change this from I to 1. It says x to the 5th minus 1 equals 0. Graph them as vectors in the complex plane. Okay, good, because I don't have to change them to rectangle. I can just leave them in polar. So this is going to be a lot faster than example 3. Okay, so imagine if you're solving this equation. If you're isolating this equation, you're going to add 1. And it's going to look like x to the 5th equals 1. Okay? X to the 5th equals 1. Now, obviously, one of the solutions is 1, right? 1 times 1 times 1 times 1 times 1 equals 1. We've got 5 answers. We know right now there are 5 solutions, one of which is 1. I bet that means the other 4 are complex numbers. Okay? But that's what we want to do is think of this as a complex number. X to the 5th equals 1 plus 0 I. Think of that as a complex number. Okay, x to the 5th equals 1 plus 0 I. Let's put this in polar form so we can use the nth root theorem. Okay, polar form. If I want polar form, then that means I need r and theta. R is going to be the square root of 1 squared plus 0 squared. Square root of 1 is 1. As for theta, I have tangent theta equals y over x. Or tangent theta equals 0. Okay. Tangent theta equals 0. That looks like a 0 degree reference, right? 0 degree reference. But honestly, guys, when you have a 0 in there, it's probably going to be easier to just imagine where this is. 1 plus 0 I, think about where that is. 1 plus 0 I is this tiny little vector, this unit vector right there. Okay, that's the vector 1 plus 0 I. Okay, what's the angle? 0, right? That angle is just 0 degrees. So right now we have 1 cis 0. X to the 5th equals 1 cis 0. And so now we're in polar form. Now we can solve this. Okay? What we're going to do is we're going to take the 5th root. This is the nth root theorem. Let's take the 5th root. And so the 5th root of 1 is 1. And then we would do 0 divided by 5 is still 0. There's our first solution. Okay? Our first solution is 1 cis 0. Remember how we knew one of the answers was 1? That's what this is. Okay? But now we have to find the other 4. Okay, the other 4. Well, here's how you're going to do that. Because I know there are 5 vectors in this plane, 5 complex numbers in this plane, they're going to be equally spaced. And so I divide 360 by 5, and I get 72 degrees. So I know all 5 of these vectors are going to be 72 apart. So what I do is I add 72. 0 plus 72 gives me my second vector on the second root. Add 72 again. I have 1 cis 144. And again, I have 1 cis 216. Add 72 again, add 1 cis 288. And when you get to 5, that's how you'd know you were finished. But if you did keep going, whatever you add, you're going to add 72 again. That's going to take you to 360, which is basically 0. That's right back where we started. And so these are my 5 roots or solutions. And so this is graph them as vectors in the complex plane. So let's graph the complex plane. Okay, this will be your x, and this will be your y. Okay, or IY. It's your imaginary axis. And so we would have to go to 1. I want you to imagine a circle of radius 1. It's going to be really hard to draw this without drawing that circle in there. So go ahead and draw real lightly or dotted. Draw a circle of radius 1 so you can draw them out. 1 cis 0 is going to be right there. 1 cis 0 degrees. Now to get 72, we're going to have to kind of estimate, but that's okay. Do as good a job as you can. I'd say 72 is going to be about there. 144 here or so. Doesn't have to be perfect. 216. And 288. Graphed them as vectors in the complex plane. How can I tell every one of these has a magnitude of 1? Because it's on my circle. Okay, it goes right up to the circle, which has radius 1. And then I kind of eyeball those angles. But I've got those 5 roots, those 5 complex number solutions graphed in the complex plane. That's all I had to do. I didn't have to convert this one to rectangular this form. I had to graph it. If you look at the next slide, there's maybe a better picture of what we did. Okay, there's a better picture. Notice we had written the abbreviated version: 1 cis 0, 1 cis 72, 1 cis 144, 1 cis 216, and 1 cis 288. But it's the same thing. This is a little bit better executed, I suppose.